We've heard a lot about AI and ML today. Lots of good stories that kind of set up for this discussion, because I'm sure a lot of you are asking yourselves the same question. So what is our jobs when the machines do testing? So with all the talk about AI and machines taking over jobs in industry after industry, it is that time for us in engineering, across all the engineering domains, to start thinking about and asking ourselves, what does that mean for us? Because as we famously see, Amazon and their distribution centers are almost 100% automated. They've got machines running those distribution centers. Tesla's factories are almost 100% automated. And for any of us that came through the airports recently, we're seeing automated kiosks. There's no people there, or have even ordering burgers at our favorite fast food restaurants. We're losing that. The teenagers are starting to lose their jobs. But as engineers, we've really been comforting ourselves in the belief that our knowledge worker jobs are immune from this degree of automation. Really, that's what we've been thinking. But are we? Are we really immune from that level of automation? What are some of the tasks that machines might be better at? We've started seeing some. What are some of the tasks that us humans might be better at? And as somebody asked Tariq earlier, are we going to have jobs left? I think it is time for us to really start asking this. Ask ourselves, what's our job? Or better yet, what's our job look like? I think is actually a better question. What's our job look like when the machines can help us do testing? So for the purpose of today's discussion, what we're going to do is, for those of us that have been automating for the past few years, or maybe even into the past decade, we're going to talk about this in terms of things that we're going to feel pretty comfortable with, because what I'm going to do is I'm going to frame things in terms of automation. And what are some of the things that we are doing in our testing jobs that we could be automating even further beyond what we've been doing with our test cases and test case automation. Now, to help with that, we're going to start taking a look at the landscape of testing tasks that we do. Who was in Kevin's presentation just a bit ago? Because there was some questions that came up in Kevin's presentation about what are some of those tasks. That's going to be I'm going to take a look at some of those, and I'm going to walk you through some tasks that we've been doing. And what I call this is AI-inspired activities. So, and then lastly, what I want to do, again, kind of along the line, it kind of continues Kevin's theme, is I want to offer a playbook of how to do this, how to go back and take this. We were all inspired by Tariq this morning. Not all of us have a manager who believes in Q equals P, where the quality equals productivity. I'm sure all of us wish we did, but we don't. And so I'm going to offer up a playbook, and that's what I'm going to really walk you guys through at the end, is a playbook. How can we take this home and start thinking about and using this usefully at home? So, organizations that have progressed from waterfall to agile to scripted automation to DevOps pipeline automation, these organizations are going to be pretty well prepared to go to this next stage of AI and machine learning and analytics, because those are all good building blocks for going in and applying AI and analytics to our testing tasks. Think of this as a way to automate some of our cognitive tasks, because a lot of the stuff that we're doing right now, and we thought that we're immune from automation, we're cognitive in nature. So we've started thinking about this as cognitive automation. But there is a big challenge, and there's a big warning. Kevin talked about this a little bit ago, is it's a pretty big lift. But, and just like Attila did too, there's some huge lifts that are similar but different. So we went through Agile. Anybody that's went through an Agile transformation knows that the process and culture changes are big. When we went from Agile, we realized we needed to start doing scripted automation. Well, we had to learn programming skills for our testers. We had to become SDETs. That was a new skill. And then as we moved even further down into the pipeline side of it, we had to learn even more tooling skills. The ops guys had to get involved. We had to play nice with others. Now, when we go into this next phase of this AI-inspired types of automation, what we're going to be seeing is we're going to be seeing a lot of those same challenges. And that's why there's a little bit of caution to proceed with caution on here. There's some similar challenges. There's a big cultural change that you're going to run into with bringing AI and being the lead vehicle in introducing AI into your organization. There's going to be, one of the things that you're going to find is the thing that really is feeding AI is data. And so when you're managing, when you're learning to bring in your data to feed your AI bots and machines, that's going to drive a lot of culture change around keeping your data clean and maintaining it. And that itself drives a lot of process change. So you're going to be dealing with a lot of process change there. And then the other thing is the skill sets. There is new skill sets. Kevin did a good job breaking down the data science to the machine learning and analytics. And that's a really good approach to break it down. Different skill sets. Do you build it on your skill set? Do you learn it yourself, or do you buy it? Do you bring that in from the outside? And I'll talk about that. But I think the important thing on there is you want to know that because a lot of this work is going to be done on your data, it's your proprietary data. There's a lot of the bots and machines that you're going to be working on is going to be custom. You're going to have to build it custom yourself. So don't expect a lot of off-the-shelf tools. There's going to be some, but not a lot. So when do the machines do testing? The title of it is, what do we do? But when do the machines do testing? This is an interesting slide. I borrowed this from Jason Arbon. Jason Arbon brought this up. He's the one that's got he's got the company Test.ai. He's been doing some really cool stuff in the UI automation, especially on mobile apps. And one of the things that Jason has done is he believes we're going to be out of a job. I'm not quite there with him yet, but he put this chart together to kind of break down the types of tasks that are going to be automated through this cognitive automation mechanism in the next 5 years, the next 5 to 7 years, and after that. So he broke it down into 3 categories. He broke it down into quick thinking tasks. Think of quick check diffs when you're trying to see if there's something different on the screen, or a quick performance check from one release of your app to the next release of your app. Was there any quick checks in there? As people, we can do that sort of thing pretty quickly, or it takes seconds to think about. With bots, we're already seeing that happen. We're already seeing that happen, as Tariq showed too. The next category of tasks were thoughtful tasks, things that we spend some time on that's going to be, maybe we spend minutes, 10 minutes or less, some test planning, some test strategy, that sort of thing. Maybe some usability and negative testing, boundary testing. But then there's the contextual. This is where we get into the harder problems. Things that we have that are deep think tasks that maybe we go and rely on a lot of reference data to come up with what our approach to how we're going to test it is. This is your test planning, maybe some of your exploratory testing. Those ones are out there, but we're talking 2027, less than 10 years. So that's when we can do. Now, Ben Pring he's a futurist with Cognizant, and he's got a couple of good recent paper magazines that have come out, but he's got a book that came out, and Ben's approach on this is really interesting, and I think this is a huge takeaway for us as testers. His message is X plus AI. Now, technically, it's not an equation, but it's a really good way to think about what is X. X is every single task that we do. Think of every single task that we do in testing. And what if we were able to add AI to that? What could it do for us? Now, sometimes when you do that, AI doesn't add anything to it, because not all of the problems that we have to fix are going to be solved by AI. But it's worthwhile to ask ourselves, for every single task that we do, What would that look like if we were able to apply AI to it? So this is a really good thing to kind of think through. And so your takeaway is to do the same thing. What is X in your job, or what's X in your organization that is that pain point that may be better off letting the machines do that work for us? So this is just a mix of ideas across the SDLC, that software development lifecycle. These are some of the things directly that we do in our organization that looks across from the planning, the design, the dev, the test phases, and even the ops side of it, that are a combination of those thoughtful, the quick planning things, but the way Jason categorized the tests. These are things that could be applicable with AI. These are my possible X's in my domain. You might have others. What we're going to talk about is we're going to talk about 4 of these real quick that we started doing. And not all of them are AI in the strictest sense. Some of them are analytics-based. We started with analytics models. But it kind of gives you a good flavor of how we did it. When Kevin was talking earlier, somebody asked him, well, what other problems could you solve? These are some of the things that we asked ourselves. And then we identified what are the pain points that we have. Which ones hurt the most that might be solvable by this? So I'm going to walk through these 4. So the first one that we have is Jarvis. These were our smart assistants. And so with Jarvis, what we did is we looked at the data that we had available to us, our test history data, our defect data. We were storing that, we were tracking all that. What's our pass-fail history? I'm sure anybody that's using a bug tracking system and a test case management system has this data available to them already. We just started building an analytics-based model around this and started running reports against the data. Why? Because if we could answer some of the questions here, that would be really helpful to us. How can I accelerate the discovery of my break fix? What should I not test? It scares some organizations, but if there's a bunch of tests that I can identify that I don't need to run, I can save resources and apply them elsewhere. Our test bots, I talked about UI automation. Test.ai and pinkline.ai are some of the teams retest, is starting to use AI bots to help us walk our applications and do those quick check diffs for us. And it's a lot easier on the maintenance overhead of our organizations. The reason we're going after this is we stopped doing our UI automation a few years ago, moved down a level on the automation triangle and focused there, left ourselves exposed on the UI, but we've got more and more features that have business logic up above the UI. These sorts of tools are going to help us out immensely. Duplicate defect prediction is another one where if you started doing a lot of automation, you've probably run into this. You're finding defects really fast, but the dev team's not fixing them fast enough. So when you run your automation the next day, you've got a big pile of defects. Which ones are the new ones? Which ones are the duplicates, the dedupe problem? And so one of our teams wrote some machine learning bots to analyze logs, analyze the test cases, and predict which test failures were actually likely new defects. That's really helpful for some teams. And then the other one that we've got is Q. This is our configuration planning model. This is a really deep think task for us. And what we ended up having, so I'll give you kind of the picture on this one, is for when we're doing our planning of our test planning and our test strategy, we have to go figure out, these are physical server configurations with firmware and software. So our test matrix, our test configuration matrix, gets up into a possible 465 trillion unique configurations. We can test about 400 to 500 of those, so we better get it right. So what we're doing in here is we go back and take sales history data, we take defect history data, test case history data, we put it together, we get our smart test leads together, they churn on it for a few weeks. Much better job done by a bot. And so that's what we're doing. We're combining some analytics and machine learning to solve that problem. So at this point, I wanted to walk you through potential tasks. Those are just some potential ones that might be able to help you guys too, or that you're doing in your domain. So now, if your next step is to start reimagining testing and doing that X plus AI, how do you do it? Especially if you don't have a boss that is the Q equals P, right? We got some selling to do, because taking the lead on innovation from a test organization is a pretty cool thing to do. So I'm going to just walk you through a quick playbook. Simple, looks a lot like a development phase sort of a thing, assessing, proving, enabling, and realizing. But the really important thing here is if the way you're getting into this is because your leaders told you to go do an AI project, then you really want to guide this, because you've got some investments that you've got to prove on it. So I'm going to walk you through this real quick. The first stage, the first two phases I've actually kind of blended together, because any of us that have gone off and done proof of concepts, this is what this stage is. But the very first thing you start off with is what's your pain points. Assess why you're doing this, assessing why you picked the X that you picked. So pinpoint your pain points after you've done that evaluation landscape. The third thing you want to do is understand, and if you've got the data science expertise and skill set on your team, you probably don't. So you're probably going to go need to get a partner to help you with that in the early stages. And don't be shy about doing that. Because what the next step after that, and they'll help you do this, is they will help you collect and analyze and visualize. They'll help you collect the data and then visualize the data. See if there's some low-hanging fruit and patterns that they can discern from your data. They'll help you select a model, or whether it's going to be an ML algorithm or an analytics model, and then build the prototype. So that's the first step, because you're just trying to prove out an idea. Is my X solvable by anything in this space? The next phase is the enabling phase, but this is a little bit different than just a peer development phase, because in this phase, you really want to make sure you understand what your business case is, so you can demonstrate the value back to your leaders. So is it reduced risk? Is it eliminating some time out of your schedule? Is it increasing is it redeploying your resources to other high-value activities, which is what we're trying to do. Then you want to go in and make sure you got really deep stakeholder buy-in, because you want to pull in subject matter experts that know what X is that you're working on. You need them. They're going to help craft that model or the algorithms. Is it on track? Is it right? And then the third thing in this phase is the data cleansing and the data curation, because when you get into this stuff, it really is about the data. Data is driving everything. It's got to be clean. You got to keep it clean. There's probably going to be process changes involved in that. And then it's time where you do the fun stuff. The fun stuff is implementing your models, coding it, connecting up to your data sources. That's kind of the equivalent of the development phase. And then the last phase is realizing. This is where you start demonstrating, you're deploying your model, you're deploying your algorithms out there against X. And now you're starting to collect your dividends and start hoping to realize your dividends on it, and checking back with your stakeholders, is it delivering? But this is a really important part, because at this point, you're not the one selling the value of AI anymore as the one taking the lead on the initiatives. Your business stakeholders are the ones that are doing that for you. So it's super, super important here. So to wrap things up, what's your job? What is our job, or what does our job look like when the machines do testing? Well, first of all, don't panic. We've got work to do. But you want to capture your data. You want to make sure every data source that you've got at your disposal, whether it's defects, whether it's test cases, whether it's your logs, whether it's configuration history that you've run tests on, save all that data, because that might be useful to help you predict future actions. Start with why. That's making sure you understand your pain points. Really understand your pain points, because if you don't know what your pain points are and you get an external company to come in and help you, they're going to kind of nudge you into pain points that they've solved before. It might not be your top ones. Establish that deep stakeholder engagement so that they become your voice piece for success for the future projects. And reimagine testing. Thank you.
Thank you very much. That was really excellent. And now time for the questions.
All right. In your opinion, is the threat of AI taking away testing jobs? Oh, wait a second. What happened to that? Oh, there it is. Okay, I started reading it, so that one gets it. In your opinion, is the threat of AI taking away tester jobs more of a long-term threat, decades, or is it already happening in the short term? So the answer to the first part of that question is yes. I think it is off, but I think the message that we got from Tariq's is that message of inspiration of this being an opportunity for testing to take the lead in innovation in an engineering organization is spot on. So I want you to embrace the idea of how can this help us? What's our X? What can we do better with X and bring it into our organizations? Because one thing I didn't talk about in today's presentation is the importance of what value we as humans bring, right? We as humans bring a lot to the value creation process. So all that work that we do within sprint teams to help create value and assess requirements, we're gonna need that for a while. So, all right. Do you think, okay, so did I do that one? Yep. Okay, what do you think about of the future of manual testing? Do you think AI can take over exploratory testing too? So, on the future of manual testing, I want to make a distinction. I'm a huge Michael Bolton fan in test theory. And one of the things Michael Bolton talks about is testing versus checking. So the testing, when I talk about testing, I'm talking about the testing that happens within a sprint team where you guys are trying to get to done on a user story, right? And so there's testing that's going on in there. You could be testing requirements, you could be testing ideas, you could be testing design. That's a manual, to me that's a manual activity. The manual testing that happens outside of the sprint team, Michael Bolton calls checking. And that's, a lot of people call that regression testing. That stuff there should all be, we should be getting to automation in that space very fast. Whether it's scripted automation or a combination of analytics or machine learning. All right, what is the best way to improve our knowledge in AI? So I took a hack on that one because I didn't have a whole bunch of resources to go study this. Kevin was in here earlier, 2 speakers before me, and he had his team go off and start learning machine learning. I went and hired, at Dell, we had a whole analytics team. We had a whole nother organization of analytics and machine learning group that had been busy applying AI to other business processes, our pricing, or they were doing sentiment analysis. They were using it to all these other, they were applying AI and analytics to other parts of the business, not engineering. And so when I found out that we had that organization, I called them up, pulled them into our team. So we haven't gone down the path of starting to train our testers on AI and ML and data science yet. We've actually hired that capability into the team. But it's a good thing it's not a bad path to go. You can either start learning it yourself or you can borrow it. And if you're in a big company and you're gonna go down this path, I would urge you to look around to see if there's other organizations that do machine learning and analytics within your organization, because they're gonna be more than happy to help you in engineering, because for them it's a new space that they haven't been in. All right, is in the enabling step, what is your favorite strategy of data cleansing? This is the worst part of this whole thing. There is no favorite part in this. In the data cleansing piece, it's so hard because you've got to go figure out, you got to go through and clean your data. And what I mean by cleaning data, you know, when we're writing up a defect and we're testing in Windows 2016 or something, how many ways could Windows 16 show up on our defect? W2K16, Win16, Windows 16, that's data cleansing. It means the same thing. The machines don't recognize that. So we have to go through and clean it up. And so we have to change processes to do that. So it's not a fun thing. It's usually around, so I don't have a tool or a technique. The only technique is getting people together to understand why it's important to go do this work.